Howdy and welcome back. In this video, we're going to introduce the positional number system, and then we're going to talk about the binary number system. We'll begin by kind of considering the decimal system that you all probably remember back from grade school. I remember fond days probably in kindergarten, just learning to count in base 10. I remember later on in my elementary school education having to do multiplication tables. I don't remember if we did division, but there was a whole kind of experience with the decimal number system that began from a very early age. And now maybe you've interacted with the binary number system before, maybe not, but we're going to move out of base 10 in this video into base 2. But what we're going to see here is that these positional number systems, whether it's base 2 or base 10, are all going to be they're going to have very similar characteristics. So what is a positional number system? So any positive integer that is greater than 1 can be chosen as a base for a positional number system. The decimal system uses a base of 10. The binary system uses a base of 2. Such a system will then use B symbols for the integers, known as the digits. So you'd have 0, 1, all the way through B minus 1. So the digits in the decimal system are going to be 0 through 9. Now, any integer n can be represented by a sequence of those base B digits. For instance, in base 10, we might have seen something like 1012 or 1012. This is simply a sequence of those base in this case, base 10 digits, 0 through 9. So we have one digit here, 2, another digit 1, another digit 0, another digit 1. I mean, we could have had alternatively a sequence of like 8, 9, 7, 6. But again, we can see here that an integer number, some integer number n, is simply going to be represented by a sequence of the digits in our positional number system. And then kind of the key takeaway at this point is to realize that where a digit presents in the sequence is going to have an implication in terms of kind of its how much it is contributing to the overall number or integer value. For instance, we can see here that that 6 is going to contribute simply 6 to the overall number. That 7, based on its position, is going to contribute 70. That 8, based on its position, will contribute 800. And then that 9, based on its position, is going to contribute 9,000. And when we add up all of these values, what we're going to get is 9876. So we can see here that the digit at some position is going to be the place value of that position. And to find the number, it's simply going through and adding up the digit multiplied by the place value of that position to come up at the actual integer value expressed. So here, that would be 6 times 10 to the 0, because we're at position, in this case, 0, starting from right to left, and that's going to evaluate to 6. We're then adding 7 times 10 to the 1, which is going to be 70, plus 8 times 10 to the 2, which will be 800, plus 9 times 10 to the 3, which is going to be 9,000. And adding these together again, we get that value, 9876. And the key to take away here is that as you're moving from right to left and evaluating this sort of integer value, in our example here in base 2, we would go ahead and call, oops, I did not mean to erase. We would go ahead and say the value 6 occupies position 0, 7 occupies position 1, 8 occupies position 2, and 9 occupies position 3. And that's where we got these values here, where n is going to be the position. So we can kind of think about any of these digits within this number, 9876, contribution to the overall number by looking at, or raising it rather, to its position, to the base, to its position. So again, that's what we showed here. So kind of moving on from this, let's talk about the binary system. So this is simply going to be a positional numeration system using base 2, the 2 digits that are going to be used here, which as we talked about up here is simply the symbols that we can use are going to be b minus 1. So in this case, if b is 2, we'll only have 0 and 1 as the digits in the binary system, and we're going to call these bits. Binary numbers are going to be composed as a sequence of bits, and they can have an embedded binary point, just like in the base 10 system, you could have something like 3.14 in binary. As a new number system, you could have something like 101.101. This is fine, but what we're going to see is that when we're talking about storing, say, binary numbers within the computer, well, we're not going to be able to just encode a dot somewhere in that number. So due to this, I'm just going to kind of focus on binary integer values or binary numbers without the fraction part for the majority of this video, and kind of continue through that until we hit the floating point values. And we'll talk about how we can represent a floating point value as a binary integer, so without a fraction part, and we'll see it's kind of an interesting encoding scheme to do that. But most of what is presenting here is what we talked about for the base 10 system. Again, we just have less digits, and we'll see here that as you move from right to left, the contribution of a particular binary digit in a binary number is going to be raised to a power of 2 instead of 10. So if we had the binary number 101 and we wanted to know what this encoded in decimal, well, remembering back to our placeholders, and I'll use some lime green here, that's position 1 or 0, excuse me, this is position 1, this is position 2. So to go ahead and calculate this out, we would have 1 times the base raised to the position, which is 0, plus 0 times the base raised to the position, plus 1 times the base raised to the position. And if we go ahead and add this up, what we'll see is we're going to have 1 plus 0 plus 4, and that's going to add to 5. So 101 is going to be equivalent, is going to be the base 2 equivalent of 5 in the decimal system. So we can see here that a lot of what we've talked about or I guess not what we've talked about, but what you've learned in grade school holds true here when it comes to binary numbers. It is going to be a little, kind of funky thinking about this with only 2 digits kind of on and off like a light switch. But we're going to see here that you're probably more familiar with binary numbers than you may think, just kind of coming into this. And we will, acquaint you a bit more as we continue to go through this section on positional number system and with particular focus on the binary number system. So with that, I want to go ahead and just move into some simple conversions between binary to decimal and then back from decimal to binary. We'll speak briefly about binary addition, and then we're going to get into data representation in the computer, which is the kind of primary topic of today. So with that, I'll go ahead and see you all in the next video.